Alright, this is on empirical and molecular formulas. And so first we need to define empirical and molecular formulas. An empirical formula indicates the simplest whole number ratio of the different kinds of atoms that make up that compound. So empirical, if you think it kind of sounds like pure, meaning the simplest ratio. Molecular formula indicates the exact number of each type of atom that makes up a particular compound. And so what this actually means is you've got your actual ratio and your simplest ratio. And sometimes they're the same, sometimes they're different. For example, I'm sure many of you are very familiar with this compound. C6H12O6. That would be a molecular formula because it's showing the exact type or the exact number of each type of atom that makes it up. You have 6 carbons, 12 hydrogens, 6 oxygens, but that's not the simplest whole number ratio. The simplest whole number ratio would be CH2O, meaning that you have double hydrogens than you do carbons and oxygens. So for the glucose example, it has a different molecular and empirical formula. The molecular formula is the actual compound of glucose. The simplest whole number ratio of that would just be CH2O. Now when solving these story problems or word problems, there's a little rhyme to remember all the steps. And so if you remember this, then you are going to be golden. So it goes percent to mass, mass to moles, divide by small, times till whole. Okay, so from now on, when you are doing empirical or molecular formulas, remember your steps are percent to mass, mass to moles, divide by small, times till whole. So a sample problem dealing with empirical formulas. The percent composition by mass of a compound is 56.6% potassium, 8.7% carbon, and 34.7% oxygen. Determine its empirical formula. So always, even if it's not written, which it most of the time won't be written, you are going to assume that you have 100 grams. And so it's really easy to convert percent to mass if you had 100 grams. So 56.6% K would turn into 56.6 grams of K. Um, 8.7% carbon turns into 8.7 grams of carbon. And 34.7% oxygen turns into 34.7 grams of oxygen. Alright, so your first step is done, percent to mass. Step 2, and I'll do this in a different color. Step 2 is going to be so percent to mass, mass to moles. Alright, so you have all your masses, you have to now convert to moles. And so you've got to set up your conversion factor. Grams potassium, match your units diagonal, per 1 mole on top. Now your grams of potassium is going to come from the periodic table. If you look up the mass, it would be 39.1. Your carbon, set it up the same way. Grams of carbon goes on the bottom because they need to match diagonal. Mass is 12.0 grams per 1 mole. And oxygen, grams oxygen on the bottom per 1 mole. And mass on the periodic table is 16.0. Alright, so if you calculate all of those out, This is now getting, you did percent to mass, and that's in green, and then mass to moles is number 2, step 2, in pink. Oops. First one would be 1.45 moles of K. Your carbon should be 0.73 moles of carbon and 2.17 moles of oxygen. Alright, step 3 was, so we did percent to mass, we did mass to moles. Your step 3 is divide by small. I'll do this in purple. So what you're doing is you're looking at your three numbers, 1.45, 0.73, and 2.17. You are going to determine the smallest of those three, and you're going to divide all of them by your smallest number. So your smallest number is 0.73, so we divide every single number by 0.73. Because this is going to give us our ratio. The first one equals 2, the second one obviously equals 1, and the third one equals 3. So your step 4 is times till whole. But if you notice, these are already whole numbers. 2, 1, and 3 are already whole numbers, so we don't have to do step 4. So what this tells us is that your empirical formula is going to be 2 potassium, 1 carbon, 3 oxygen. And that's going to be your formula, your empirical formula. And so you would write that as K2, C, you don't need to write the 1, O3. Okay, so K2CO3. Alright, so sample problem using molecular formula or finding molecular formula. The problem says the analysis of a compound indicated that its empirical formula is C2H4O and its molar mass was 176.0 grams per mole. What is the molecular formula of this compound? So it gives you the simplest ratio, which is important. It gives you the molar mass, and you have to figure out the molecular formula, so the actual ratio. So first thing we need to do is look at the empirical formula, that's C2H4O. And we need to find the molar mass of this so that we can compare it to the molar mass of the molecular formula, which is your 176.0 grams per mole. So finding the molar mass, you need to take your carbon. You've got 2 of them, so 2 times 12.0. Hydrogen, 4 times 1.0. Oxygen, 1 times 16.0. Add these together and you should get 44.0 grams per mole. Alright, so your empirical formula, C2H4O, has a mass of 44 grams per mole. Your molecular formula has a mass of 176 grams per mole. So we need to see how many times bigger the molecular formula is than the empirical formula. And so we need to divide those numbers. So your big number divided by your small number. I take 176.0 divided by 44.0. And this is going to tell you how many times bigger it is. If you divide those numbers, you get number 4. And so that means that your molecular formula is 4 times larger than your empirical. So if your empirical is C2H4O, your molecular is going to be C, and it's going to be 2 times 4, H, 4 times 4, O, 1 times 4. And you don't ever have to write it out like this. I'm just showing you how we're going to get those numbers. So your final answer for your molecular formula would be C8, H16, O4. And if you add up them, if you find the molar mass of that, you should get your 176.0 grams per mole. And so that is the difference between your empirical, which is this one, and your molecular.